Alright. Hey guys, I'm going to go ahead and explain heat and enthalpy for those of y'all who did not get to do this so far. Right. New app. Don't know what I'm doing yet, so... Alright, let's try this again. So, talking about heat and enthalpy. Keywords, these 7, you do need to know. So, I know it says law of conservation of mass. It should say, and it says on your paper too, should say energy. Okay. Total energy of a closed system remains constant. Energy is not created or destroyed, but you can change it. That's what, sorry about that, that's my son. It's when energy changes its form. Okay. Also remember, chemical reactions are either going to absorb or release energy, most often as heat or light. If it was lost, it left as heat. If it was gained, it was absorbed as heat. Okay. Alright, so on here, I know you don't have a lot of space. I do recommend you write, however, exothermic reactions release heat. The products have less energy, and I recommend you write this equation. I actually had room in mind. I could draw the graph. You don't have to. Okay. An endothermic reaction absorbs energy. The products have more energy, and heat is a reactant. So that was all review. New stuff. Activation energy. Okay. All reactions require energy to begin. Hello, Alex. Say hi to my students.
Hi, students.
They're not in there. I'm making a video for them. Okay. Activation energy. The energy required to start a chemical reaction.
Mommy, get out of me.
Hi, Alex. It's this hill right here.
Oh. Well, look at my hill.
Okay. So, activation energy is part of our graph for energy change. And it relates to what's something called enthalpy. Enthalpy, which is represented by H, is the total energy of a system. Okay. And it has an equation. Okay. What we're calculating is the triangle H, the delta H, which we call change in enthalpy. It equals the heat absorbed or lost during a reaction. Okay. Okay. So, enthalpy is something that whenever you're creating or destroying a compound, it's going to exist. So, enthalpy of formation is the change in enthalpy required to make 1 mole of a substance. And it equals the heat absorbed or lost, also called heat of formation. Basically, it's how much energy do you need to create that substance. Like how much energy do you need to make carbon dioxide, oxygen, water? And we can actually calculate that. So what you do is you add up the enthalpy of formation values of the products and then subtract the enthalpy of the reactants. These will be provided on a table. I will put the table on Google Classroom for everybody. Okay. Alright. So, some things to remember when you're calculating enthalpy. Since their units are in kilojoule per mole, you need to multiply by the coefficient. Also pay attention to state of matter. Notice we got water, here is liquid and gas. We have to pick the right one. And then all elements
Mama.
have a value of 0. Okay. Basically means all elements, even ones like
Do you feel a wilbur?
O2.
Mommy, do you feel better?
Yes, I do. Thank you, Bug. H2.
Yay.
All these ones circled in red, they're free to make.
Did this work?
Right. So, as I was saying, all elements on the periodic table,
Oh,
even if they're diatomic like O2, H2, N2, all those are going to be 0. They're free to make. All right. So this is the sample problem that you had on your slides. Mine just has the answer. So what we're going to have to do is figure out products and reactants. We've got
Mommy, did you bigger?
H2O gas. So if we look, H2O gas is negative 241.818. That's right there. Okay. CO2 is negative 393.509. That's right there. Pay attention that they multiplied by the coefficients. If you're making 6 waters, you're going to have to multiply that number times 6.
Bye.
And if you put it in your calculator, just like this, your product should value at negative 3,024.94. Okay. Now let's take a look at our reactants. So we have C2H6 as a reactant. Its value is negative 83.5, and we have 2 of them. Notice, just grab a different color, oxygen is not on the table. That's because its delta H value is 0. If they're not on the table, most likely they're 0. So when I multiply 2 times negative 83.85 plus 7 times 0, get negative 167.7. So, for this math, it's products minus reactants. So my negative 3,024.94 minus negative 167.7. That gives me, you put that down right now, son. Put the tray table down. Negative 2,857.2 kilojoules. This is the energy difference between the reactants and products. And since it's negative, that means it's exothermic. It lost energy. And by the way, delta H would be that little place right there. Okay. All right. So then we have another one. Okay. Again, we start with products. 4 H2O gas, so negative 241.818 again. And 3 CO2, which is negative 393.509. Multiply them by their coefficients, and then add the 2 numbers you get together. Gives me negative 2,147.799. Now when you look at products, C3H8, which is negative 104.7, that's the amount of energy needed to create it, plus 5O2, which is 0. Gives me negative 104.7. Alexander, put that down, please.
I did.
Off the couch. Okay, so now we look. Negative 2,147.799.
I need to go ice skating.
Minus negative, he thinks he comes with minus negative 104.7. Sorry, gives us a value of negative 2,043.1. So this one's also exothermic.
This is beer.
look, there's this one. Hear that? My 4-year-old thinks this is easy.
Me.
I don't think he has any idea what I'm doing, though. So let's take a look at our products. Oh, look. Our products are both diatomic elements. Neither one is on the table, so they're both 0. So our products are 0. Our reactant is H2O water. So we're going to use negative 285.830 this time. And we multiply it by 2 because there's 2 of them. So in this case, when we look at it, because the products were less than the reactants, this one is endothermic. Energy went in. So which means this graph would look something like that. And this would be your delta H.
Mommy, the bathtub is not full of water.
Yes, I'm not putting water in that bathtub because you spilt last time. So if delta H is negative, it's exothermic and releases energy. So energy would come off. If delta H is positive, it's endothermic and it absorbs energy. Energy would go in. All right. Thanks for listening. I will be posting something. It might be like a class kick on a Google Classroom with some little practice for you, okay? It might only be like 3 problems. Okay, I'm going to be making more videos for this week and posting them online. Take care of yourselves. Stay well.